In previous classes, you've probably talked about finding the slope of a line, which you may have described as rise over run, or more specifically, you may have used this equation, y1 minus y2 over x1 minus x2. And the reason it works is because we just want to find the slope, the rate of increase in a constant line. Well, as we get towards calculus, we want to start talking about finding the slope of a curve. Well, it's a bit harder to do because a curve is obviously curvy. However, what we'll do is we'll start talking about something called an average rate of change. So we'll imagine picking 2 points on our curve and then finding the slope of the line that connects those 2 points. And so it'll kind of estimate the slope of this curve between those 2 points. We're going to use this exact same formula, which again, you may have used it backwards, y2 minus y1. As long as the y's are on top and as long as you're consistent, it doesn't matter how you do it. Let's go ahead and take a look at how we'll find the average rate of change of a curve using the slope formula. So let's find the average rate of change for this parabola, this quadratic equation. And let's start by finding the average rate of change between 2 and 5. Well, first thing to note, these are x values. And so what I want to do, I just want to get a real rough sketch of what this graph might look like, just to kind of visualize what's going on. So I don't know what this is going to look like. I mean, more or less I know it's going to be a parabola, maybe something like this. And so what they're saying is pick 2 x values, maybe the point 2 when x is 2, maybe that's about here, and maybe it's about there. Maybe when we pick a point where x is 5, maybe it's over here. And so my average rate of change would be the slope of that line in between there. So I can see that it should be a positive slope. Well, all we need to do then is find 2 coordinates, and then I should be able to use my slope formula. The first x they gave me is 2, the second x they gave me is 5. And so what I want to do is find the y values that match up to those. Well, there's a couple ways to do it. One way is I could actually go ahead and plug in those x values, and so I could do 2 squared minus 2 times 2 and then add 3 to it. Or what I would recommend doing is just using your graphing calculator, entering this into y equals, and then checking your table to find these. Either way you do that, and you may want to pause the video and try that just so you can find these values. Either way you do this, I found out that 2 gets you an output of 3, and then 5 gets you an output of 18. So again, you can check those on your table, or you can plug those values in and just see that that's what you get. So let's go ahead and take these 2 points then and do our slope formula to find the average rate of change. And so I'm going to do y1 minus y2, and again, it doesn't matter what order you subtract in as long as you're consistent. So I'll do my that order on top with the y's always on top. And then the bottom would have to be 5 minus 2 to finish slope. Okay, so if I go ahead and simplify this, I end up with 15 over 3, or a slope of 5. So my average rate of change is going to be this 5, or 5 over 1, to describe the steepness of that line. Okay, let's go ahead and try one more, although if you think you've got it, you might want to pause the video and try on your own. So this time we want to find the average rate of change between -2 and 0. And remember, those are x values. And so the first thing I'll need to do is find the y values that match up to those. You can plug those values in, the x values, into your equation, or use your calculator to check your table, and that would be a quicker way to do them. While you're doing that, or I guess I'll talk a little bit, although you could pause the video. Once again, I want to refer back to my sketch and kind of predict what's going to happen this time. When x is -2, maybe that's some point over here. When x is 0, that's got to be some point down here. And I can see that this time, the line connecting those 2 points should have a negative slope. My average rate of change should be negative. Okay, let's see if that turns out to be true. Hopefully by this point you found your y values. -2 gets you an output of 11, and 0 gets you an output of 3. So there are my 2 coordinates. We're going to go ahead and do slope formula, y1 minus y2 over x1 minus x2, and see what happens. So I'm going to do 11 minus 3 this time. My y's always go on top, but this time I decided to subtract in that order. Just make sure you're consistent and subtract the x's the same way. So -2 minus 0 would have to go on the bottom. This works out then to be an 8 over -2, or a slope of -4, which, as we predicted, did come up to be negative. So my average rate of change between those 2 values is going to be -4, or -4 over 1.